Well, do you guys remember this kind of stuff?
No.
I mean, I do, but I don't remember.
I
remember
sort
it
of
enough
do.
to not have it on the final.
Yeah, it is on the final.
Just
Oh, well,
two
this is
questions, right?
Not this question.
I feel like if the
Something like
majority of the questions are circled, they should be fine.
Well, it's not the majority. It's proportional to being the last unit that we haven't tested, but the majority of questions are other questions. It's probably, I mean, I didn't count. I would guess it's probably like 35 to 40% circles.
Oh, that's
And
Okay,
then,
so
good.
the test for the circles is gonna be like included in the final.
Yeah.
Okay.
Which is
That'd
Yeah.
be rough having like 2 tests back to back.
true. Like do one Monday and then one Wednesday.
Oh my.
Each what?
We're
One
only
test.
taking one
Can
test.
I use all of my note cards for all the other
Nope.
ones?
not here.
But we do get a note card.
You can have one note
Are
card.
you still doing
Oh,
the
the big note card or like the tiny
It should
little...
just be like a sheet of paper.
You need
like
I was thinking like, I don't know.
Oh, no, thank you.
Bro, I can't
all
draw
of
a
us-
picture of the sun on that note card.
We
I don't wanna see
all
it.
will fail.
Hey, I would,
You
yeah.
know.
You said
I
you were
would just
gonna put
Pass gracefully.
equation key on it. Are you still gonna do that?
An equation key.
What?
I don't, not an equation key.
We don't even need
Can't
Like
remember.
formula?
Yeah, formula.
No, I'm not doing that.
Okay.
No, darn it.
So I'm just gonna have to write down every formula and what they're using.
I'm just gonna have to write
And
down
like
every
when to
formula.
use them.
Yeah, exactly.
I'll probably
Use
focus
this
on the
in this
parts that I
specific
don't
case
have
as
to.
probability.
Alright, so this table sets up to be a two-way frequency table, but what's missing from it?
The totals.
Yeah, the totals need to be put on there.
18, 32,
And what should be true as we add horizontally and vertically?
they to be equal.
Yeah.
Which is 50.
Alright, so a little review of notation and what it's asking. It says find the, well, you guys tell me, what does this say?
Did not exercise.
No, I want it in
No.
probability
What
language.
is the probability that someone did not catch cold knowing that they did not exercise?
Okay, it's the other way around.
Oh.
That was this one. So knowing is the second part, and then we're asking the probability of the first part.
Oh, did not
And remember the line is given that. So probability that they didn't exercise given that they did not catch a cold. What does that mean? Yeah. So that is our category. And then we ask out of them how many did not catch a cold.
2.
I did it wrong. Hold on. No, I didn't. Never mind. Did not exercise was 2 out of 32. Okay? I'll put it just over here.
Okay, so I did this somehow. I did it right.
Okay, the next one is just the reverse of that. So probability that they didn't catch a cold given that they did not exercise. So now we're in the second, remember the second one defines the category, so we're in that category. And then did not catch a cold would be 2 out of 12. That was too fat. Okay. So are the events did not exercise and did not catch a cold dependent or independent, and explain. So first of all, are they independent or dependent?
Dependent.
Okay. You guys both disagreed. How do you guys remember how we check?
Oh wait. They're
No.
independent.
Alright,
I missed-
there
I
was a
missed
little
what dependent.
Formula, and it was this. And remember there were two versions of
Oh,
it.
times A.
Not times, but just
Called P.
is the probability of A knowing B happened the same as the probability of A whether or not we know that happened? That was the independence check. In other words, was the probability influenced by knowing some other event has already occurred? Does that sound familiar?
Yeah.
Okay. So what's, and then A and B, like I said, you could rewrite it as B given A and probability of B.
We can do not catch a cold.
Okay.
Given that it's
So he wants. Let's just write it.
just 1
No cold.
given
Given that no exercise.
Yeah.
And then what goes here?
Deny. No cold.
What am I doing? N-O. There we go. Okay. Well, we already did this one. Which one was this?
1/6.
Yeah, that was number
yeah,
3.
number 3.
So this was 1 out of 6. How do we find probability of no cold?
Total
Yeah.
total of not having a cold
So
out of
this
total of people.
column, 32 out of 50. Well, that's clearly not a 6.
No, it's 6 is 4%.
Okay.
So, which means it is independent.
It is not.
It is okay.
Right?
Wait, what?
So it's not independent.
Oh, okay, that makes sense.
I don't know.
So it says to explain, and here's one version of that. It's not independent because the probability is influenced by knowing they didn't exercise. No exercise. This would be like saying, I don't know, let's put it, I mean, this sort of could be connected, I think, maybe, but like, what's the probability of passing the final given that you studied versus just in general, right? Like, if we know somebody studied, the likelihood of them passing is probably higher, right? It changes the probability. If I just said pick a person at random and said, are they going to pass the final? And it doesn't just have to be this class. Let's just say you stand in the hall and I say pick some random person, are they going to pass their math final? And you'd say, well, what percentage would you guess?
2%.
2%.
80, what? 2%?
Okay, if
What
I
kind of
said,
final
hey,
is this?
this group of people walking by all studied yesterday in a study session, what's the probability that they'll pass?
5%.
Do you see how it changes? You're not going to probably say 2%. You'll probably say, oh, it's higher now, right?
3%.
That's what this is. It's if you know some condition, it changes the probability of the outcome. Okay? Here's another version specific to us. You guys are all really good at math in this class. So if I said, you are,
I'm not.
for sure. If I said, what's the probability, to just maybe out there, ask somebody, what's the probability that one of my students will pass their final? In general, well, maybe it's 60%. But if I said, what's the probability that one of my students in this class will pass? Now it's 100%, okay?
Yeah.
Just saying. I have no doubt that all of you will pass with flying colors. Okay?
Good job.
I wish I had the same confidence.
Well, I do. I have confidence in you.
Can we do like practice?
Right now?
Like, very, like,
I don't think that's a very effective way to review. I mean, it's not that I'm unwilling, but
how do you just review like math? Couldn't you just do a problem?
Honestly.
And then you know, like, right away, if you get it right.
Yeah.
true. All right. Anyway, let's check your homework. Let's start with this page. These pages. We did do all of them, right? Yeah.
Yeah. I don't know. We're gonna do
Just
this.
Oh, that's too big.
Oh, that's no. Oh, I have.
There we go.
I
Okay.
got that.
So go ahead and just check real fast if you can, please.
This one. Not that is Christ. Okay.
I'll totally forget all of this.
I did
Am I
mine
going
all
too fast?
backwards.
Okay.
So what you
It's just know this like
did? 40. Wait, how can you get 84?
Okay, 80.
Oh wait, I'm just done.
Wait, how? What? How?
Would have thought.
Oh,
Oh, okay,
Basic
okay,
edition.
yeah, no,
Okay.
never mind, I see that.
Good, 7.
But also,
Wait, 80?
Wait, 110.
I got
Sounds like there's a lot of questions today.
Oh,
Up
wait,
there,
because
yeah,
that's the
yeah,
measurement
looks
of
like it.
angle. FEP, not L. Yeah, that makes sense.
how did
I literally just found the wrong angle.
Okay, so this one, FP is 70 because it's opposite of this 35 and remember it's double. And then FPD is a semicircle.
Oh.
So subtract 70 from the whole thing. The whole 180.
Yeah, wait, I technically got it right. I just found the wrong thing. I even wrote FP equals 70. So I solved what I wasn't supposed to.
Okay.
When I get
That's-
everything.
I don't know, I got 80, so I just screwed
Alright, next page.
Okay, I got that one.
What's true about opposite angles in an inscribed quadrilateral? Supplementary, not congruent.
In this case, I don't know. I like solve for the rest of the thing by using the supplementary, but that ended up leading me to get the wrong answer, and then I just used like the ones that were given, and I got the correct one. So I don't know how that worked. But.
Alright, I forgot to write the answer down for this one, that's why.
Probably.
That was wrong.
Because remember, like
Yeah,
we got like 8, and then I just used like the 2 ones that were given, and then we got the correct one.
Yeah, it's not that you couldn't use the angles in there in the quadrilateral. You just didn't have to. We did that one
Yeah, I got
yesterday. You
that
guys remember? Number 9. I posted it on the classroom yesterday. All right, 3, 3. Both of those are x equals 3. One.
That's for. Oh, okay, I got this.
30 and 2 38s on that one. Good so far?
Just like, I mean, 13, I don't know. I got 23 for some reason.
Okay, I got that one right. Oh.
You got what?
23.
For which one?
13. I don't know if I was bugging.
This-
You just add both the
Can I?
arcs to 180, right? Or add them both together and then set it equal to 180, and then you solve for x.
Let's come back and do that one after we finish checking.
Yes.
All right, number 15, 16. Because you had to set up a system of equations on those to solve for both variables.
That's probably.
Preferably in standard form, using elimination would probably be the best option. Okay, how did those two go? 15 and 16. No? Did you even do?
I did do that.
Okay. Do you want to do one of them?
Yeah.
Okay.
Times 2.
Let's check all that we need to on this page, and then we'll check the Doom practice one. So we'll do 13 and 15 or 16.
Times 2. Oh, I forgot to calculate.
All right, so Gabe suggested adding 7x minus 10 and 13x minus 10 to 180. Why would he say that?
Because there's.
It's a semicircle, right?
Yeah.
How do we know that?
Is the diameter goes through the center.
Yeah, it's because we're showing that that's the center.
We're assuming.
We're not, actually. It's okay to... Well, alright. I guess slightly we're assuming that this doesn't, like, veer off over here,
So
Right.
Yeah.
that we can't see. So I guess technically we're assuming that it is a diameter. Often these problems will say anything that looks like a diameter is a diameter.
So LN is.
No.
It does not look like a diameter.
It could to me.
Alright, so we get x to be 10, and then this would be 60, and this would be 120. And those are the arc measure, And then the question's asking us for NLM, so back in here. So half of 60 is 30. So that works.
Okay. I just did wrong in the algebra part.
Okay.
And I didn't get it.
Another way you could do this is to know that this is 90. How do we know that for sure?
Because they're perpendicular.
No. No. What? Yeah, it's the inscribed angle for that diameter.
Oh yeah. That,
Keep your eyes out for that. Those are really helpful.
We got a
know
30,
that.
16, 90.
So we have
That's just 36.
90, and then angle N is half of 13x minus 10. And angle L is half of 7x minus 10. And then you can just add those three angles to 180. Either one. Does that help? I mean, it did because you said you found your error, right?
Yeah.
Okay.
Yeah. What I did is for the negative 20, when I was transferring over to the other side, I made it 160 instead of 200.
Okay. Do you have a preference on which one of these we do?
50.
6 looks more. 16 looks.
Okay, you got it right.
I mean, I got 16 right. So that wasn't a problem.
Yeah, why? I
They
mean,
look confused.
well, the one more surprising is
Okay, so remember that opposite angles in an inscribed quadrilateral are supplementary, so I would start by just writing those relationships first.
that's why you set up to 1 million. Confused about that part.
Okay, so we have two variables, two equations. That means we're allowed to solve. We're not allowed, we're able to. If we had two variables, only one relationship, we couldn't solve. That's too many variables. But this is not in a recognizable form. So we should get it into, well, I guess you can choose. This is standard form, and let's see if we did dx plus ey equals f. Do you remember how we try to match coefficients and then add or subtract to get rid of them? One of the variables, okay? You can do it that way, or you can do substitution. I personally probably wouldn't do substitution, but it's fine. So let's call this equation 1 and 2. So 1a, if I rearrange all this stuff, it's going to be 7x plus 2y, and then we have 1 plus 74 on the left side that we need to subtract from the right side. So that's subtracting 75. Okay, over here for 2a, we have 6x, 2y, and then 100 minus 10 is 90, so that makes this 90 on that side. Good? Any questions on where those came from? How do we combine them in a way to get rid of a variable? Yeah, we want to subtract to get rid of the 2's. They're already the same coefficient. So 7 minus 6 is just 1. And then 105 minus 90 is 15. And then how do we get y now that we know x?
We plug it into one of our other equations. Like
Yeah, and we have 4. Which one would you pick?
I would pick
6 plus
2a.
This number 2a?
Yeah.
That's what you said too?
Yeah.
So 6 times 15 is 90. And so as soon as you see that, you know that it's going to just be 0. So our two variables are 15 and 0. Does that help? We'll be solving systems of equations in Algebra 2 pretty much right away after break, within the first probably week. In Algebra 2, we extend this to do 3 variables with 3 equations,
Ooh.
and
That's cool.
it's a fair bit more work, but it's the same stuff. You just have to do it more times, is all.
more room for error.
Yeah, that's true.
That'll be fun.
Yeah, it is kind of. I'll show you how to use your graphing calculator to solve it in an instant, which is cool. We might have time to talk about matrices, where we could set these up with the matrix and then solve it without any letters. It's just all numbers. Well, like this equation, if we wrote it in matrix form, would be 7, 2, 6, 2, and then 105, 90. And then we just do all our math on this structure instead of this stuff.
How would you
Oh.
do that?
Same kind of idea, but if we have time, we'll learn matrix operations.
Well,
what
actually,
we
that,
can and can't
that,
do.
that kind of makes sense.
It's kind of cool. I hope we have time to do it.
It looks cool. I hope we can.
All right. So, any others on those 2 pages? Let's check the other one. It kicked me off. Or maybe I'm just on the wrong one. Or maybe I have no idea what I'm doing.
All those pages, yeah. I can probably.
I had it open somewhere.
It's probably the one right next to it.
This one I had a problem with.
Shoot,
I
you're
would-
probably right. Yep, it was. Oh well. Alright, so this first one was just terms. If you did it, go ahead and make sure you're
Oh, it was terms.
name.
Oh.
Well, that explains. I literally put not enough information
Oh
and
my
just moved on, bro.
I hate that they're written tests that have not enough information. Now you always think it's an option.
Yeah, bro. Nah, I literally spent 5 minutes just looking at it like, huh?
There's one on your test that is going to challenge you that way. You might think it has not enough information and you might think it's okay. I'm interested to see how you read it.
Hey, that's
Is
not
there
very
enough
obvious.
information though?
There are
Depends
tests.
how you read it.
No.
And I'm not going to try to trick you. It's not like that.
So is there enough information or is there not enough?
For real, it depends how you read it.
Actually,
So, does that mean depending on how you read it, there's a right or wrong answer?
No.
so you can read it wrong and you can
It
read it right.
depends how you justify it.
Okay.
It's a multiple choice question. If you just circle multiple choice answer and you don't tell me anything, then it's wrong. But if you show me why you pick answer, I'll take 2 answers if you have proof as
Okay.
to why. Does that make sense?
Yeah,
That's
I
why
like
I'm saying
Okay, so basically just a proof.
no, it's not a proof.
Is there
That's why
proofs
I'm
on it?
saying it depends how you read it. When I was doing it, I read it one way and then I checked what that problem comes from the book and they read it a different way. It's because their notation is stupid. That's why.
Yeah.
Anyway. But always read the directions.
Well, I mean,
Any questions on those? I just want you to start thinking of this. It says it on the page for your test, but a lot of the problems are multiple choice, but it says right at the top, if you have to calculate something, you better show work. Even if your answer is right, I'm not giving you credit.
wait, the
On a
final
multiple choice without work.
is multiple choice.
Huh?
The final.
Some of it.
Thank you.
Wait,
You
so
still have to show work.
we have to
Bro,
show.
there's a reason I like NWEA, bro.
Oh, okay.
When it comes to like testing, it's just everything's multiple choice, so you can just plug it in.
Do you want to just do this one, or did you just want to ask a few questions about it?
Just verify the answers. I mean,
Okay.
it's relatively simple. As long as you like understood like the first step.
I got confused and screwed myself up.
Your hair like.
So like I have a question about the final.
No,
So if we have something set up like this, 7x plus 2 is equal to 10 or whatever, 16 let's say. Would you have to show a minus 2, or can you just move on to 7x is equal to, instead of putting
that's
cool.
Okay.
That's like, so as long as you can see like what we did.
Yes. In fact, like you're on your way to doing math that way.
I really put.
Yeah.
Showing every little step is not.
I
It's not like a next level math thing, right? That's like a learning math thing. So it's fine.
I don't like doing that because it actually takes too much space and it cuts out space that I have to
Oh
write
wait,
stuff
what
in.
happened is I mixed these up.
Right. Any others?
That's one of the
Can I
places.
get which one?
fine.
Just two.
This stuff is really simple and nice and fun.
Any questions on any of these?
Nope.
Good? Nate probably has one that he's taking a nap. Alright, so
Shame.
that is the end of inscribed angles. Why don't you grab your notes? And let's talk about secants. We're going to have 2 days on secant stuff.
Today.
We're going to talk about secants today and tomorrow. And don't draw this, I just want to give you a heads up. Secants intersect the circle twice. We'll write that in a second. It could be a line through it. It could be just a ray starting on it. Or maybe it's from a point going through the circle. Okay? So think of just shooting something through the circle. That's a secant. And so one of the things that, like today we'll focus on only secant and chord angles. So we talked about this I think yesterday, but how would we get those two if we know that they're not located at the center? So they're not central angles, they're not on the circle, so they're not inscribed angles. So how would we get the measure of them? They're the same, do you agree?
Yeah. Sure, there are. Oh, yeah, because it's
Because they're vertical angles, right? Those angles are the same, but obviously their arcs are not the same. Okay? The arc measure is not the same. So how do we figure that out? What if we have something like this, and we want to know this angle? So now we're intersecting an arc here and an arc over here. Okay? And maybe I give you the angle and ask you for the arc.
So would you look at the proportion of how the angle grows?
Did you say
Or
grows?
the arc grows.
Yeah, well, it's going to have a relationship between these two.
Yeah.
Wait,
The two
is
pieces.
it gonna be like?
Is the bigger one 2 times of the smaller one?
No, but that's a good thought.
Is
Yeah, good job. I like this.
Is the smaller one in the angle component?
No.
Is the small one? Like
There's going to have to be
forward?
an addition sign in there. Just to give you a hint.
Oh, you
The
have
radius
smaller
or
one.
distance from the circle, because the distance
And
from
it
the
actually
circle.
does, it does depend on that, but that won't be factored in because we'll know the arcs, either the arcs or the angle.
Okay.
Wait, is it gonna be so like to find the bigger one? Is it gonna be the angle plus the smaller one times 2 or something like that?
Yeah, something like that. Okay. So tomorrow then we'll talk about like what if this is x and x plus 4 and this is 10 and this is 14. So we'll switch gears tomorrow and talk about lengths instead of angles. Make sense?
Yeah.
And there's a lot. There's a lot of formulas. I think we'll end up writing 5 or 6 different ones. And so you'll have to keep it straight. Is it an angle? Is it a side? Is it a secant angle, like I drew a second ago, like something like this? Or is this an inscribed angle, or a central angle, or an angle formed by maybe a secant and a tangent, or a tangent and a chord? That's not this one. Remember that yesterday? That one?
Nope.
What was that one? Let me clean up my picture a little bit. Tangent, chord, talking about that angle.
Oh.
How do you find that? Okay,
Half of the
Oh, that was.
that's tangent, chord,
Oh,
half
yeah.
of the intersecting or
arc.
Yeah.
So it's half of this arc right here.
Okay.
Okay, guys, please listen to this advice. I don't want you to put faith in your note card because having it on there sometimes gives students a false sense of security. And you're like, oh, I have it. I can just look it up. But there's a lot here, right? Even just with circles, we're going to end up having probably 10 or 12 formulas. And if you're kind of lost on them and you're just hoping to look it up, you're probably going to pick the wrong one, or maybe pick the wrong one. So spend some time trying to get them memorized and linked to the correct type of problem. Okay. All right. Let's get into the notes and just start writing some stuff about this. The very best case scenario would be have your note card for an emergency but never need it, right? That would be awesome.
I probably think the last one is tied to the, how about the, I'm putting up lights.
So switching gears from chords and inscribed angles to secants. Can anybody, without looking, tell us the progression of things that you've learned in this unit? That kind of review and knowing the progression can help you kind of put stuff in boxes, like, oh, this was that kind of formula situation, and this is this. Without looking at your notes, what did we start with?
Yeah.
Circumference, diameter, radius, area, and which is circumference. No, before that.
All right, central angles.
No, before that. So we'll keep that for the next thing. Remember equations of a circle?
Right.
Oh, how to find
yeah.
the
X minus h squared plus y minus k squared equals r squared.
Yeah.
That's on your final. Make sure you know it. And then we graphed it, we figured out how to find the radius, how to find the center, that kind of stuff, right? Okay. Then we went to arc length, central angle, sector area, segment area. So we started getting truly into circles at that point. Well, circle formula kind of stuff. Okay, then from there we went to tangents, and we had, remember, tangent radius was perpendicular. Tangents from a single point outside the circle were congruent, okay? And made a kite in that case. And then we went to inscribed angles, which is, or not inscribed. Yes, inscribed, that's what we just finished, okay? And now we're at secant angles specifically today. So a secant, just by definition, is a line, ray, or segment that intersects the circle twice. Let's draw a picture. Kind of like the one I just had. So there's a secant. But you could also have from a point, like maybe we have two secants coming off of that point. So they're not tangent, they are not necessarily congruent, right? Even just in that picture, do you see how we might have to solve for, here, look here. We might have to solve for that angle. Let me pick a different color. That angle there, maybe this arc, that arc, or that angle, or the two arcs that those two intersect. And we've only drawn 3 lines, so there's lots of solving potential on this. Maybe. I mean, it's not necessarily hard math. It's mostly just you got to remember which one to use.
This is all of it.
Yeah. Well. No.
So you kind of just.
You just have to keep it straight as to which scenario, like which case you're dealing with. That's all. So even the solving isn't super hard or long.
Yeah, it's just there's a lot of stuff you can pick from.
Yeah. There you go. Okay. If they intersect inside, so like the top. Like that. So let's say intersect inside. So that's going to create interior angles, or angles inside of the circle is what I mean by that. This time let's draw that scenario before we show the equation. When you draw yours, try not, here just look before you do it. Try not to have these look like they're on the center, okay? Because if they're on the center, then it's just the central angle. Right. So let's try to make these obviously somewhere else, like that. So two secants are intersecting interior or inside of the circle, and therefore they are intersecting or intercepting two arcs. A little one and a big one. Or we could say near or far from the point, whichever one works for you. Let's put some letters on here so we can actually write a formula. And we need one in the center. Okay. So measure of angle AEB. Here's the big deal. It's 1/2 of the sum of those two. Half the sum. Now, what about CED? What about measure of angle CED?
Double, like 2 open parentheses, and
Well, isn't it vertical to the one we just wrote?
Yep,
So it's the same. In other words, either side of that, it doesn't matter which one you're solving for, it's congruent, right? Because they're vertical angles. I guess we don't need the M for this to be proper. Those two are congruent, they're vertical. So keep an eye out for using vertical angles. And again, if I on our picture asked you to solve for the left side or the right side, it's the same formula for both. Okay? I see some faces. Are you good?
Yeah. So the one on the right,
Yep.
the top right, is a C, right?
Yes.
Okay.
Sorry
Thank you.
about that.
I agree.
Any other questions?
Have you ever hit clear the whole whiteboard after you had like almost a whole page?
Like this?
Yeah.
Thank goodness for undo.
Well, like
Yes, I have done that.
just without knowing that you could just undo it.
We'll write some exterior angles, but let's look at a couple of these first. Okay, if AD, measure of arc AD is 155 and BC is 61, what is the measure of angle 1? So, kind of just talk me through that process.
I thought that was saying that angle degree is 1.
Yeah.
add
It does look kind of weird. What was it?
add the two.
And did I write
Yeah.
Yeah, keep
That's all. I wrote it as times a half, but you could also add them and divide by 2. Either one is fine. What about, in this one, could we answer a question about angle BAE?
Where?
Right here. What if I want to know the measure of that angle?
Well, wouldn't it be
180 degrees.
So it would be whatever angle 1 is minus.
That would be BE.
I mean 180
BEA, sorry.
You just subtract.
Yeah, it's a linear pair with angle 1, right? So we still have to bring the things we've learned about just intersecting lines or maybe triangles or vertical angles into this. So just knowing these 2 arcs, now we can solve for the whole thing, because once we have angle 1, take a linear pair to get the red circle angle, and then we could get both of those as well. Is that true?
Wait,
No, it's not.
I thought- yeah, I thought
It's not true because I would have 2 variables in here, right? I like it, I can see thinking. Let's say we knew the circle was 80 degrees.
The what?
Isn't it going to say this? And then we're like, oh crud, I can't solve for 2 variables with 1 equation, right? So, keep it in mind though. We could solve for BEA and we could solve for CED, either of those angles, but we won't know the arcs, so don't. Are you good on that?
Yeah.
Okay. Okay.
Oh wait, never mind. I don't have a question.
You sure?
I take it back. Yeah.
Okay. Alright, so this is the exterior ones. There's 3 cases. I'll draw them with you in your notes, but just take a look at the difference. Like this is 2 secants from a common point intersecting with the center inside of it. And then this one, it doesn't have to have it in, it could be anywhere like that. So secant tangent and then tangent we already did. But we didn't talk about the angle. Do you remember that? We didn't, when we did tangent, we didn't talk about that angle related to the 2 arcs.
Oh.
But the good news is they all have the same formula. Roughly. Like it's the same idea. So, how do I want to say this? Intersect outside, I guess. So somehow let's kind of make this stand out as separate from what we just wrote, but still in the same category, same secant section. Okay, let's draw the 3 pictures first. Alright, get your lines drawn. We're going to add some more information on each one of them, but get those lines drawn first.
My tangents are not very good.
Huh?
My tangents are not very good. They kind of run along a circle for a minute.
So do mine.
When you have a tangent, it makes it look like
They're not all
like
one
a
time.
cone.
Oh, mine tangent. Cricket.
Well, I think
Well, it looks like bird feet. Well, depending on the bird, if you draw
It
it,
was going so good.
you basically say how tangent.
birds don't really have many, not many birds have triangles.
Well,
Okay.
I know, but
So,
that's like
don't change your picture. It's not a big deal. I just want to show you something. That this one, it could be, if the center's here, it could be that kind, where it doesn't have the center in between. It could be the one we drew. Okay, obviously it could be on the other side, like both of them down here. Doesn't actually matter. Okay?
Those are two different shades. Very quickly, you changed the color.
You're right, I did.
Yeah.
Okay, this first one is secant, secant, two secants. This one is secant and tangent. And this last one is two tangents. Again, what's true about the two lines of the tangents?
They're congruent.
These are congruent, but we haven't talked about how to find that angle. That's what we're doing right now. Okay. I'm just going to put some kind of notation in the angle that we're solving for. And the good news is all three of these are the same formula. What is wrong? There's an extra bump in there.
Yeah.
Oh my goodness. No matter which case it is, it's the same. So that's good. Okay? So really, what do you have to identify?
What?
The lengths of the line.
Like, to not get confused, you need to identify that this is exterior, not interior. Right?
Yeah. Yeah.
Okay. And I know that's probably obvious, but do me a favor, just so we don't have to write it 3 times. Just call each of these angle A, or put an A at the point, so we can just write it once. Measure of angle A, and I'm going to have to redraw this blue thing one more time, so I can fit it on. So, measure of angle A is this 1/2 the measure of the far minus the measure of the near arcs. If you don't like the word far and near, because maybe it doesn't work for you, call it something that makes more sense. Like you could say maybe the bigger one and the smaller one. Yep. If you want, you could add in the pictures, just name them. So this is the far arc from the angle, this is the near arc. Same here, far, near. Usually it's pretty obvious.
What would an example be where it would be?
Well, I guess this case, it's still obvious if you use far and near, but if you use big and small, it may not be quite as much, because they're a little bit closer to the same size.
So with the tangent, it's still, or even the secant tangent, we're going from like near, since it's all the way up until it touches a circle and you cut it off, considering it to be the arc.
Oh, yeah. Okay, so he's asking what do we define the arc as? Yeah. Now maybe that would be worth highlighting. So just where the lines touch the circle is the cutoff, is what he's asking. Which is a little bit weird on those kind, because they stop at the same point.
My nose is getting so messy. So we're going to start.
Okay, so if you're using the words big and small, I want you to think about, don't draw this, but if my point was way out here,
Oh my.
you see how it's not super obvious which one's bigger or smaller? But near far is obvious still, because whichever one's closer to our angle, okay? Okay, what's another point that you could get confused on? Look at the last two formulas we just wrote.
Oh, the adding and subtracting.
Yeah. Okay? The angles inside we add and take half. The angles outside we subtract and take half. Absolutely could be a point where you get mixed up.
Inside was half.
So, any questions on that? Let's go look at some problems. Oh man, we haven't done a proof in a while.
Oh.
We thought wrong. No, we are. Let's see. Okay, so look at this one. Is this secant, 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 tangent, tangent, tangent? That's secant, tangent. But we're given this arc over here. We know we need that one. What do you do? In order to find this angle, we need the near and the far arc. But we're not given this one, we're given CD.
You add them together and subtract them from 360.
But we're
Yeah.
given AB, right? That's not showing.
Huh?
AB is 151.
Oh, yeah. This is 151. So, yeah, you're right. Just add these, subtract from 360 to get arc CA. And then you can go ahead with your formula. So you can see how we can twist these a little, right?
It'd be
Or we can
70.
stick X's in there.
It'd be 70 degrees.
Let's
See
set
that?
this one up. Okay, thanks. So 1/2, is it add or subtract?
Subtract.
Good. So 1/2 of 151 minus 70, which is, what is that? 79? No.
Isn't that 130?
51
Yeah,
and 30 is
139.
81.
So I don't know.
81. Did you do it right?
Yeah.
Yeah, it would be 81.
Holy moly, we have numbers flying everywhere. I have no idea where we are.
81.
Well, I know the difference is 81, but is this for sure 70? Because they were saying something about
Oh,
that.
yeah.
Yeah, that's
And then, so what is the measure of this
Yeah,
angle?
it's so
They call it AB.
It's 40.5 is the
Yep.
angle measure.
Good. All right, let's try one with X's. How would you set this one up?
You would do
Yeah, you just don't.
34 degrees is equal to 1/2 of arc angle. Yeah,
Okay, let's plug in stuff. We know this is 34.
that is equal to 1/2
And how about the far arcs?
6x plus 6 minus.
Okay, be careful. Look here. What do you need next? What's the next thing I should write? Parenthesis, because I'm subtracting this whole thing, right? If you just write minus and then put 3x minus 5, you will not change this to plus 5. And then it will be
Oh, okay.
so 3x minus 5. So, guys, it's the little things, right? Conceptually, it's not a big deal, but little things can throw you off. How are you going to get rid of this half?
Multiply it by half.
No. It's already multiplied by half.
By 2,
Okay.
but you have to do it to both sides.
Yeah. That just takes care of it right away. Minus 3x plus 5. So if you didn't use parentheses, you would miss that plus 5. That's what I was saying a second ago. And then solve from there. So 3x, this is 11, subtract 11, we'll get 57, and whatever that is. It's 19?
Yeah.
Okay. Everybody good? It says what's the measure of arc LM. You just plug 19 back in and you're good. Okay, are we adding or subtracting on that top one? Why are there like big ugly marks? That's weird. Adding or subtracting when we solve that top one?
We are
Adding, because we're back interior. Adding or subtracting on the bottom?
Subtracting.
Okay.
Tangents.
Alright. Segments, that's what we'll do tomorrow, I think. Let's see how this